The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.
I'm so glad Max has agreed to be on call 24/7 so he can document every excruciating second of this really complicated project.
Yeah, we've been filming for 48 hours straight.
Well, don't worry, Max. Only 72 more hours left to go, give or take. In the previous episode, we started testing the Pixie color tracking camera, and we were able to get data from it to a microcontroller. We also found some stepper motors to use. In today's episode, we're going to finish the project by attaching those stepper motors to a linear rail to move the camera back and forth on the x-axis, and also building a mechanical pan-tilt mechanism so the camera can look up and down. Once we have all that working, we will program, wire, and test it to track this object on a work surface. Let's get started.
Amazing builds, exclusive mods, cutting-edge ideas, electronics, engineering, and more. Every week on Element 14's The Ben Heck Show.
This is something that Element 14 gave us about a year ago, and we really haven't used it a whole lot. It's a slider, so you can make nice professional sliding camera moves, or you can make the camera go to and fro if you're Alfred Hitchcock. We'd like to use this for our motion tracking camera. So obviously the camera would go here on this mount. So we need to make a mount that connects to the mount for one thing. And then on the ends, we'll make pillow blocks and 3D printed holders for a stepper motor. So you have a stepper motor here, a belt, a pulley, and the belt coming back. So just like a 3D printer, the stepper motor can move the camera back and forth. That'll be the X axis. And then there'll be a Y axis for tilt. So it can find what it's looking at and look down at it. Actually, if we had two of these, we could make a really nice giant 3D printer because this motion is really smooth and there's no wobble at all. It's almost like this is professional camera equipment. Yes, you can use your $800 camera equipment to make a $500 3D printer. Call now. I still have plenty of stepper motors laying around from past projects. I would buy these at surplus stores and I'm like, why am I buying so many stepper motors? But eventually they get used, so yeah. I already had this one drawn into the computer. You can see it here. And to be lazy, I'm going to use the same pulleys that we used in our double-decker printer. All right, so we have a drawing here. It represents the motor and the pulley. And the size of the pulley is important because that's going to tell us how the motor and the carriage relate to each other. So if the motor's here and the pulley is this big, that means it connects to our moving platform at, such and such position. I drew the end cap into the computer here, and I did it in two views. And as usual, I'm doing this in 2D and 3D just because I guess I'm old-fashioned. So here's the end view. The cap has a threaded screw mount on it, and it's a standard camera, which is a 1/4-inch English screw, or imperial. I always think of the Empire from Star Wars. And they're like, dun, 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 your metric system is not good enough for me. Admiral Nida. Okay. Great, I'm probably gonna get hate mail from Star Wars fans saying I misquoted that. All right, so here's the top view. There's also a mount here. So you know what, if we can put 2 screws into this, we should. That'll make it nice and tight. So just to make sure I've got the measurements right, I'm going to laser cut a piece first because it's much faster. All right, here's the piece off the laser. Let's see how we did. The laser is obviously 2-dimensional, but this is a good start. Okay, so there's one of our screws. Stepper motor here. Yeah, that looks good. 3D printing things is slow, so I use my laser to do a quick real-world test like this to make sure everything fits. Then once I know my dimensions are correct, I 3D print it. Because that's going to take about an hour to print, and I want to make sure that that is time well spent. Even if you don't have a laser, you could print this on some paper, cut it out, and still have an actual size template. I do that a lot too. I just use the laser because I felt like it. Let's see if this fits. Looks okay. Little warping on the print, but it should be fine. Now I'm going to print a pulley. I 3D printed these parts. We have this, which is a mirror image of the first end cap, but it's got a few differences. Mostly, it just has a null pulley on it. There's no motor. So we're gonna put that there, and then this is a pulley pretty much the same as the pulley over here, although we have a metal shaft through the middle of it so it can rotate freely. So let's put these together. I coated these 3D printed parts with acetone to improve their strength. The point of failure for 3D prints is almost always the layers splitting apart. So using acetone can help seal those layers together. So we're gonna go screw, washer, put that through, and then on the back or the bottom, there's going to be another washer and a lock nut. Time to add the belt. I need to connect this camera carriage to our belt. I've 3D printed a couple parts. Here's our first part, and it's got some slots in it that match up to slots that are already on this carriage. And there's also a screw mount here. Strangely, even though all the other screws on this are English, imperial, this screw is metric for some reason. And I also printed this, which has notches in it to grip onto the belt. And these two pieces will bolt together into the carriage to hold the belt in place. So let's attach it. The belt's not quite long enough, but that's okay, because we can cut it. Like Blood Street. All right, I'm gonna slide the ends of the belt into the teeth, making it as tight as I can. There we go. Tighten the screw and it should be good. Okay, that seems to work. Now I'm gonna build up from here, making something that attaches to this threaded rod so the camera can be mounted. Time for the next parts. This is my camera base. It has mounting holes here that will attach to a standard camera mount, which hasn't changed in like 30 years. It's basically a 1/4 inch screw, so it's imperial, and then a little tab goes here in order to keep it from rotating. And I haven't built the thing this mounts into first because I wanted to make sure this worked. So we're basically going to attach the pulley to it and have it move like that. And it'll be belt driven, so the motor will sit back here, driving a belt, move the camera up and down. All right, so I've got my 8mm shaft here. Shaft. So the shaft will notch into the last part that I build, and it will rotate on that shaft. I made sure my hole was a little bit bigger than the 8mm shaft, so there's some tolerance. That way it fits together nicely. In a perfect world, you could make an 8mm hole and put an 8mm rod through it, but the perfect world doesn't exist unless you're Kevin Costner. So I'm going to add some more acetone and actually physically bind these together. We'll see if it attaches to the camera. Then if that works, we can continue the rest of the design. The pulley has been sealed to the camera base. There are holes in it that allow us to put through the mounting screws. There's one here that will attach into the little nub on the camera, and a larger screw that will actually mount it. So we made sure that there's enough gaps so the screw would basically just drop right in. Comes up there. This screw is threaded, so this smaller screw just stays in place like that. Let's see if it works. I offset the center of the camera a little bit so I would be able to screw this in. Otherwise, there would be a metal rod going through it and I wouldn't be able to reach it with the screwdriver. So it's offset just a little. This screw actually would intersect with the rod, but you only have to put that screw in once. So once you put the rod in, it doesn't matter that you can't reach it. Yeah, there we go. So the idea is this will sit here and it will lock into a mount that we haven't made yet. The stepper motor will be back a little ways, and there'll be a belt between these two. And so when the stepper motor moves, it will cause this to tilt up and down. Now it's time for a tech timeout. We're using bipolar stepper motors, which means there are 4 wires coming off of them. These are the most commonly used for projects and 3D printers and stuff. You can also use a unipolar motor in the same way, you just don't use the 5th and 6th wires. So there are 2 windings inside of this motor. They're doubled up, but you can think of it as 2 coils. And you might not always know what coils are connected to what wires. Here are some ways to find out. You can touch 2 wires together and you'll feel more resistance when you turn the shaft manually than when they're disconnected. That can find a coil, or you can measure their resistance. If you cannot find any connection between 2 wires, then you know that's not a coil. If you find 20 to 40 ohms, that is your coil. So I know that the pairs are blue and yellow, complementary colors, nice, and red and green, also complementary colors. Conspiracy theory, you be the judge. I have what I believe to be the final pieces printed. We have the mount for the camera that goes back and forth. Then I printed it in 2 pieces. The rear portion is what holds the motors. So a little bit of a lip here for where it connects to the carriage. I'm going to use some acetone to make sure this is very nicely sealed. I mean, we have screws as well, but we want it to be really good. So I'm going to acetone it and then move on to the next step. Ah, the sweet smell of acetone. It's a party all up in here. I put a lot of structure in here to make sure it wouldn't crack. I might even add some more acetone, but I think it should be pretty good. Also, by having the motor back here and the camera up here, it counterbalances it a little. At least that's my plan. It might not work. And then the mounting hole, you can also go through it in order to screw this onto the camera. I sort of planned that ahead of time. I'll just tell people I did. So I'm gonna put the nut on to attach this to the linear rail. I'll put the belt on, because we won't be able to do that later. Loop it in, bring this over, stick in the 8mm rod. Hope the belt is tight. It can be a little tighter, but it should work. Okay, then I made this little cap here that will plug in the other side of the rod. I'll put some screws through that. I'm using the tap on these 3D printed screw holes so they don't crack or break. I guess cracking would be breaking, so again, redundant. When I design things like this little cap, I keep the size of my screws in mind. I thought, oh, I'll use 1/2-inch screws, which means this cap is thick enough to prevent the screws from going too far and hitting the pulley. I hope there's no mirrors near this thing, otherwise it's going to see the hot green reflection in the mirror and it will be like the Twilight Zone. There we go. I probably won't be able to go too far back before it hits before the camera would hit the motor, but it'll be able to tilt a good ways down. And that's fine because this thing will probably be like, 5 foot, and then it'll be looking down at something most of the time rather than up. I highly doubt it would ever go past this plane. Our cameras never do in the show. That's my excuse for my design flaw. It's not an excuse, it's a reason. Okay, I'm gonna take this apart. Might as well install the camera. Now we'll see how much the camera's weight will affect it. All right, we're pretty much done with it mechanically. Now that just leaves the electronics. I'm 3D printing the hopefully final part. While that happens, I'm going to wire up the drivers. I've got these easy stepper motor drivers. I've used these before. They're pretty easy. And I think they will give us smoother motion than the one that we tested with in the previous episode. I'm just going to arrange them on this PCB. It's probably decent. So you've got your X motor, your Y motor, and the controller. Going to add a plug so we can attach the power supply, and there'll probably be an external plug for the switch I talked about. So once I have this in the position I want, then I will go into the long, boring task of wiring it. I've got the stepper motor drivers hooked up for a looping demo. It's going back and forth, forward and back. Seems to be working pretty well. The forward and back has a few issues. I think the belt needs to be a little tighter, so my measurements were slightly off. Other than that, I think it should work. Here's the board I wired up. It has my AVR driver board on it, along with 2 stepper motor drivers, and this is the power supply input. We also have some jumpers here so we can set micro stepping, half step, full step. And there's a jumper right here which sets if the AVR board is being powered by the power supply or the programming cable. Once I get this working a little bit better mechanically, it'll be time to attach the Pulley sensor so it can move on its own. We need to mount the Pulley module to the top of the Canon as best we can. So we want it to be centered on the lens and as close vertically as possible. So what I want to do is use the accessory mount shoe and have it plug right into that. So what I'm going to do is I'm going to draw this into the computer and then extrude a 3D shape that will hold this and fit right into the shoe. All right, let's see. Here's the shape on the screen. I am moving it around. This is me eyeballing it to make sure it works. Looks good. All right. So it's a pretty simple shape. We basically just extrude up about 3/8 of an inch, and then at the bottom here, we have a lip so that it will fit into the shoe tightly, just like any other accessory for the camera. Let's print this out and stick it on the camera. Now that we've done a basic motion test, it's time to use the Pulley to drive the stepper motors. I've attached the Pulley to a 3D printed camera shoe mount, which will plug into the Canon right here. There we are. It's just going to be looking for left and right for this initial test. Always do things one step at a time. Plugging in the Pulley to the SPI bus. Plugging in the main power supply, and then plugging in the jumper to activate the program. I haven't done any ramping or speed throttling, none of the things you're supposed to do. Looks like it's working. Felix, can you take this a few feet away and let's see if it still works? There's a dead zone in the center of the screen of about 25 pixels. So it has to move past the dead zone in order to start moving. All right, this looks good. Let's put the Y-axis in place. To test out the camera, I'm going to simulate a work environment. I'm going to have it track different things that I might be wanting to show to the camera. We have an on-off toggle button here, so when I tap it once, it goes on. When I tap it twice, it goes off. So I tapped it and it's searching for the object. I'm going to turn off. Okay, now blah, blah, blah. Look at this fine Corinthian leather. Now look at the next object. Track. Oh, here is a circuit board. Slightly above it is a GoPro. Don't know what to get your wife for Valentine's Day? Check out this rock. It's not diamond, but hey, it's a big rock. Oh, it's so meta. The Pulley is looking at the Pulley box. Mind blown. And then my face. Hey there, camera. So if I don't click the button again, it'll keep continuously tracking. But when I have it where I want it, I hit the button and it's locked in place. Sorry, Max. I think it's taken your job. In this episode, our challenge was to use the Pixie color tracking camera to build a motion-controlled video camera that would follow an object we place on our work surface. The camera worked quite well, so I feel we met the challenge successfully. I like how the camera's tracking can be toggled on and off with the big red button, and it seems like this would work pretty well for a single person filming operation. Things I do differently, it would be nice to have the Y-axis work a little better. Even with this light Canon HD camera, it would tend to tip over on itself. Perhaps a counterweight would have helped with this. What would you have done differently if this were your build? Any ideas on how to improve what we have already? Let us know in the Element 14 community. That's all the time we have for today. In our next episode, we're going to be finding a purpose for old laptop LCDs. We'll see you then. I didn't see Max's car out there. I wonder if he's coming in today. But for the price of a cup of coffee, you can adopt a stepper motor. Only about 72 more hours to go. No, son, don't save me from this tornado. I want to die. Leaving your mom financially disabled because there's one less person on the farm. It's okay. I will dismember you. But we're not Alfred Hitchcocks. Plural, there's multiple Alfred Hitchcocks. You're tearing me apart, robot. Also, don't do drugs.
The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.